Hello friends, welcome to our website automationcommunity.com. Today we are going to see a very useful topic from industrial point of view. So that topic is alarms and tower light programming using PLC and HMI. Friends, to differentiate any abnormal conditions in industries, each machine has one tower light showing different light color indications. And in HMI also, there are different alarm messages coming. So this programming and HMI designing we are going to see in this topic. So let's start. First of all, here I have tried to create one HMI screen from where we can simulate different type of faults, and based on that we can see whether the alarm is coming, whether we are able to reset it or not, and tower light in different conditions. So first of all, if there is no any fault and machine is on, so what will happen in the tower light? Yellow light will be blown. After that, under the normal condition, this is a high pressure switch and this is the low pressure switch. This is the TDH and pH of the water. So what I have tried to do, different sensors are used in different machineries, but I have tried to cover most of the sensors that are used in industries. Okay. So these sensors belong to different machinery. So here we have assumed under the normal condition, high pressure switch should not be on. TDS and pH also should not be on. Now what is this? Actually, there is the TDS and pH controllers or meters in the industry, and there are the sensors. And that controller has relay outputs like common NO and NC. And that outputs can be used to start dosing pump or to give feedback to PLC. So here we are not going to discuss about the pH sensor, TDS sensor or its controller. Just we will use its NONC contact that is coming to PLC. So in the normal condition, HPS switch, TDS and pH and temperature, all three should be off and temperature should be low. So in that condition, yellow light will glow. Now from the screen you can see I have also tried to make different buttons, like if we press the cycle on, that means whatever will be our logic or code, based on that our automatic cycle will be on. So if we click on the cycle on, our cycle will be start, and that can be indicated by green light. That means automatic cycle is running. And when the user presses the cycle off, that means the automatic or whatever the logic we have written, that cycle will be off and machine will be in idle condition. So in that case, yellow light will be on. Now assume that if there is any fault, any sensor gives abnormal signal, then in that condition what will happen? Alarm will be generated. That means a moving screen alarm and different alarms can be generated. In that condition, here the red light will glow. So let me show you example. So this is the example. Here you can see in the normal condition, our emergency switch is NC contact. Okay, emergency switch has NC contact, so it will continuously give power to our PLC. But as soon as we press the emergency button, its continuity is break. Okay, in that case, it will act as off button. So you can see a message is generated that emergency button is pressed, and this is the abnormal condition. So here the red light is glowing and it will be blinking red light, so that operator can know there is some problem. Besides that, I have made two other buttons like alarm button and reset button. By clicking the alarm button, we can navigate to alarm screen where we can see the alarm history and current running alarm. Actually, this is the screenshot from the different alarm, that is the high pressure switch. For example, if the high pressure switch becomes on, that means that is the abnormal condition. In that case, this moving alarm will come. So this is current active alarm and this is the total alarm history occurred till today. These things we are going to see in the next part of this video, because this is the HMI portion. In this video, we are going to cover the PLC ladder programming related to this logic. Okay. HMI designing we will see in the next part of this video. So let us understand the wiring details required for this project. Actually, we will just understand how different sensors are connected to PLC. So let's see that. So first of all, assume that this is our one PLC and this is its digital input module. So what we will do, we will connect the ground terminal of our SMPS to common terminal of inputs. Now we will give 24-volt supply to our each input sensors or switches. Okay. So first of all is cycle on and cycle off button. So cycle on button is connected to X0, cycle off is connected to X1. After that, there comes the level switch. Now in the industries, some machine using hydraulic pump. So in that case, we need to observe the hydraulic oil level. Some other machine has coolant pump, coolant water. So in that case, we need to measure the coolant level, and some also has the lubrication pumps. In that case, also we observe the lubrication level. All that condition level switch is used. Now level switch has NO&C contacts. So it is kind of switch only. Okay. So what we will do based on our application, either we will connect it on NO or NC. In common, we will give the 24-volt supply. Here we have assumed it is connected in NO condition. Okay. Here we have assumed the NO connection. So 24-volt supply will be connected to common and its NO terminal will be connected to X2 terminal. Okay. Now comes LPS switch. What is the LPS? LPS means low pressure switch and HPS means high pressure switch. Generally in the compressors, chillers and refrigerations, there is two pressure switch in the compressor, low pressure switch and high pressure switch. Also in the industrial RO water system, there is also low pressure switch and high pressure switch. Again, this is also NONC context, how it is used and why it is used. Let me tell you. So low pressure switch are generally connected in NO terminal, means when the desired pressure is achieved, then only system should work. Okay. In the industrial RO pump, it is used to detect whether the sufficient water is available with sufficient pressure or not. So that is the use of LPS, low pressure switch. Okay. When the desired pressure is available, this switch will become on. Okay. Now what is the use of high pressure switch? So in the industrial RO purifier, if high pressure is there, it can damage the membrane. So when the high pressure switch is activated, industrial RO should be stopped. Otherwise it will damage our membrane. So what we will do, we will connect in NC. That means if the high pressure is not there, system will work okay. But if there is a high pressure, that means the NC continuity will be broken. So our system will be stopped. Okay. In this way, these two will work. Again, after that, there comes the emergency switch. Emergency switch has NC contacts. When we press the emergency switch, contacts are break. That means there will be discontinuity. So in the normal condition, high pressure switch should not be on and emergency switch should not be pressed. Okay. After that, there comes a flow switch. Now, don't confuse between level switch and flow switch. Flow switch is used to determine whether the sufficient flow is available or not. So in the industrial chillers or water chillers, flow switch is used to detect whether the water that is to be cooled is available or not. If the water is not available and chiller is still on, then it can damage the machine. So that's why flow switch is used in industrial chillers. After that, there comes the TDS and pH controller. Okay. So as I told you, In the industrial RO purifier system, TDS and pH is also maintained. So there will be one TDS sensor or pH sensor connected to TDS controller. You might be thinking, what will be the controller? So it is just like temperature controller, but it is working on TDS or pH sensor. And that controller has relay contacts like common NO and NC. So we can use that context of controller to give signal to PLC. For example, if the pH is higher than our set pH in the controller, then its common and NO terminal will get activated. So it is kind of switch only. So it will give signal to our PLC. Same for the TDS. Okay. So in this way, these are the different sensors generally used in the industry. Besides this, there is also temperature sensor in some machinery. Some machinery we have to monitor that whether the temperature is under the safe value or not. If the temperature becomes higher, then also system should stop. For example, in some motors, if the motor temperature is very high, in that case, machine should stop. Or in some chemical process also, if the temperature is higher, cycle should stop. But how can we connect the temperature sensor to PLC? So for that, we can use analog module. So here I have written DVP04PT. So what this means, this is the Delta PLC analog module. Here 04 means 4 inputs and PT means PT100 sensor can be connected to this module. And this module can be connected to Delta PLC. And temperature sensor will be connected to this module. So in this way, we can interface the temperature sensor with PLC. Now we will see the output wiring for tower light. In every industrial panel, there is one tower light indicating the different operations. Okay. So how we will connect that? We will connect the ground terminal of SMPS to common of PLC output, digital output. Okay. After that, we will connect 24-volt supply to each LEDs. Here, Y0 will be connected to green light, output Y1 will be connected to yellow light, and output Y2 will be connected to red light. So, we will remember these addresses while doing the programming. Now we will see what is the logic used in this project. So first of all, in the Delta PLC, there is one instruction A and S. Here itself it is written alarm set. That means it will set one alarm. Here you can see the basic syntax of the program. If the desired condition is achieved, in that case, this ANS block will set one bit. That bit is starting from S, okay, and its range is starting from 999. Here you can see one timer. What does this means? We can give timer value also. That means here it is writing 50. 50 means 5 seconds over here because it is 100 millisecond timer. So what does this means? If this condition remains greater than 5 seconds, then this alarm bit will be set. If this X3 is on for 3 seconds, then this alarm will not be set. But if this X3 is on for greater than 5 seconds, then it will turn on this alarm. So this is the logic to set the alarm bit. Now we will see how we will reset this. So simply we will use John reset instruction to reset all the active alarms. And lastly, for the blinking of tower light, we will use special internal memory register M1013 that is providing 1 second clock pulse, 0.5 second on and 0.5 second off. So we will use this bit to create blinking red light. Okay. So I will open my ISPsoft software from here. Let us click on the new file. Confirm yes. and we will write the name of our project and click OK. So first of all, let us write the device command list. So X0 is our cycle on button and X1 or cycle off button. After that, as I have told you, we will write the input as per this sequence. So at X2 level switch. So here also at X2 I will write level switch. X3 will be my low pressure switch. So I will write LPS switch, and X4 will be our high pressure switch. So we will write HPS switch. After that, X5 is our emergency button. X6 is our flow sensor, and X7 is our TDS or PS coming from TDS or PS controller. So I will just write like this. Okay. Now I will click on the outputs. So again, let us refer this diagram. At Y0 is our green light, Y1 is our yellow light, and Y2 is our red light. Then we will use some internal memory registers. M04 process OK, M14 cycle on, and M24 temperature is high. Okay. Now let us click on programs and right click on the new and again click OK. So let us zoom this. Here I will write the network command. So whenever we are using extension modules like analog or digital extension modules, we have to click over here. Let us select this 0, and from here we have to select type of our extension module. So as discussed in the PPT, we are going to use DVP04PT and click on the setup. So here there are different registers what we want to measure. Okay, so let us say we want to monitor average temperature in Celsius. So that is written over here, and assume that our sensor is connected to channel 1. So let us select this and click on read because we want to read this data. So it is asking what will be condition to read this data. So we will write M1000. That means this bit is always on. So we want to monitor the data always. Now here it is asking where you want to store your results. So we want to store our results in data register D0. Okay. So click on preview button. So you can see one code is written over here. If you want to add this code in our programming, click on add to list. So here again our code is written and just click on OK button to insert this code in our programming. So as soon as I click on OK, again click OK over here, you can see our instruction is written automatically. First of all, copy this and write over here, and then let us delete this. So you can see what this values means. Here 0 means station address of our extension module. 6 means the average temperature in the Celsius is stored in the 6th control register of extension module. 1 means we want to monitor one data, and D0 means we want to store our results in D0. Now we will insert network from here. Here I will write detect high temperature, press enter. So what we will do, we will do one comparison. First of all, I will insert one NO contact and give its address M1000. After that, click over here and we want to compare the value of temperature. So I will click on functions block and from here we will select it is in comparison only, and here we will select greater than equal to and click insert. So what we will compare? We will compare value of temperature stored in data register D0. If this is greater than 100, then what should happen? It should set one internal relay. Click on here and insert one output coil, and what we will write over here M2. If our temperature is higher than 100 degrees Celsius, it will turn on this internal register. That means indication that temperature is higher. Now again insert a network. Right over here sense process is okay. Now we will write one code to detect whether the process is okay or not. So for that, what I will do, first of all, I will write all my sensors starting from X2 up to X7. So either I can click on this button and then in this way I can click multiple times, or we can just write LD X5. Again I will write LD X6. Okay. Then again move your cursor and write LD X7. So there are two ways, whichever way you feel easier. Okay. Here what we will do, here we have to write address for each like this, X2, then X3, X4. Okay, let us delete this. We don't require this. And again here we want LDM2, that is temperature high. Now generally, as I have told you, level switch we will connect in NO, so let it be NO only. LPS switch is also NO, so here also we will keep NO only. Now temperature is high. In the normal condition, temperature should not be high. So what I have to do, I have to do this NC. If M2 is off, then my process should be okay. M2 becomes on, then my process should not be okay. So I have to write NC over here. Similarly, if high pressure switch is on, that means it gets activated, then my pressure becomes not okay. So what I am writing this, I am writing for process okay. For process okay, this switch should be off. So what I will do, I will write NC over here. If high pressure switch is not on, then my process will be okay. How? Because its NC will have continuity. Similarly, if emergency switch is not pressed, that means it will have continuity because it is by default it is NC. Okay. So here there will be continuity. So let it be NO only. Similarly in flow sensor, it will be NO. Now in TDS, if this bit becomes on, my process becomes not okay. So here also we have to select NC. If this TDS or PH controller output is off, that means my process is okay. So here we have to use NC. Now here we have to use our output, that is M0, that is process okay. So let us again see this. If these conditions are met, okay, let me zoom out this. If all of these conditions are satisfied, then my PLC will sense that process is okay. Now let us insert network over here. We will write one code for cycle on and cycle off. So first of all, we will check whether the process is okay or not. So we will check that by LDM0. So it just insert one NO contact. Now click over here. So here write LDX1, that is the cycle on button. If cycle on button is pressed, what should happen? So out M1 cycle should be started. Okay. Now again click over here because we have to latch this. Even if the on button is released, cycle should remain on. So here write or M1. So you can see a one parallel contact is created. Again here we can insert contacts from here also, but I am teaching you how we can do in another way also. So either we can insert contact from here or just select this portion and write LDI because we want to insert NC contact, and that is X2 because we want to stop this cycle. So you see one NC contact is inserted. Okay, so this is our X0 cycle on button and this is our X1 cycle off button. So now you can see it's okay. Everything is okay. Insert network. Now we will write code for the tower light. So first of all, let us write code for green light. So if the process is okay, that means LDM0 and cycle is on, that means LDM1. If these two conditions are met, then only green light should be on. So insert one output or just write out Y0, that is our green light. Okay. Now insert a network and write code for yellow light. If the process is okay, that means LDM0 and this times LDI, that means NC contact of M1. Cycle is not running. Cycle is not on and process is okay. At that time, we want to out yellow light. That means on our yellow light. Now again insert a network and we will write code for red light. So we will write red light in the network command. Now we want red light to be blink. First of all, when the red light will be on. So right over here, LDI M0. That means if the process is not okay, this bit will be off. This bit will be off means its NC will have continuity. So if the process is not okay, that means there is some fault or alarm. In that condition, we want to turn on our red light that is connected to Y2, but it should be blinking. So to blink this LED, just write LD M1013. So here you can see it is 1 second clock pulse. It is continuously on, but it will be on off every 0.5 seconds. So our output will also on off and it will appear like blinking. Now again insert the network. Here comes a main part of our programming. Based on the different input sensors, we want to generate different alarm messages in HMI. So for that, we have to write some code in PLC separately. So let us write alarm for level sensor. So what we want to do, if level is okay, then this switch will be on. If level falls down below desired level, this switch will become off. So if the level switch become off, so we will use its NC contact. If the level switch becomes off, we want to set one alarm. So just write ANS. Now we will select one timer T0, time period of 1 second, and we have to set our S1000 bit. Okay, so this is the one way to insert this instruction, or let me show you what is the another way. Just insert network. Now we will write alarm for low pressure switch. So insert contact from here. In normal condition, low pressure switch should be on, but if this becomes off, alarm should be set. So here also let us select NC and go to functions block, select all types, right over here A and S, and click on insert. So this is the another way to write this instruction. Here for different alarms we have to use different timers. One means this should be set our alarm instantaneously without waiting a time delay. And here we will select S1001. Okay. In sequence only we will use these bits, S bits. So in this way, I am going to write code for each of our alarms. So let me skip this step. So friends, similarly, I have write code for high pressure switch. You can see time delay is one only. That means instantaneously it should enable the bit S1002. After that, emergency. Here also I have used one timer for 1 second and it should start instantaneously. Similarly for flow sensor. Now this time what I have do, I have write 50 over here. That means it will wait for 5 seconds. Now in the high pressure switch becomes on. In that condition my alarm should come. So this is okay. If emergency switch is pressed, so its continuity will be lost. So here I will select NC. If emergency switch is pressed, its NC will be lost. So it will act as off. In that condition, it should set my alarm. After that, flow sensor. Normal condition, flow sensor should be on. But in abnormal condition, flow sensor is off. So here also I will use NC. If flow sensor becomes off, my alarm should be activated, but it will wait for 5 seconds. If this flow sensor remains off for more than 5 seconds, my alarm bit S1004 will be set. Okay. Now this instruction will only set these bits. We have to reset these bits separately. Similarly, if our relay contact from TDS or PS controller becomes on, so that is the abnormal condition. So in that case, alarm should be activated. Here I have used time delay of 3 seconds. And last, this is our temperature high bit. Here we have written one code to detect for high temperature by doing comparison. If temperature is high for more than 5 seconds, in that case, alarm should be generated. So here we have used S1006. Now we will write code to reset this control set. First of all, select this and insert network. Right in the network command, we will write code to reset alarm. If the reset button is pressed, any alarm, active alarm, if it is there, it should be resetted. So for that, we will use another internal relay because this will be HMI button only. Let us write M3 over here. And here we will write zone reset instruction. So our alarm bit starting from S1000 and ending to S1006. Now you will say, if I press the reset button, but even if the fault is there, what will happen? Once I press this button, alarm will be resetted. But if fault is still present, it will again execute the particular code and set the particular alarm. Until the fault is cleared, alarm will keep coming. So this is all about the complete programming of tower light and alarm message for HMI. It's HMI designing and simulation we will see in the next part of this topic. If you want to learn more examples like this, show your interest by liking and subscribing our YouTube channel.